The U.S. government users, especially deployed warfighters, but even back in the continental United States where they're in garrison and doing training and testing modes, rely heavily on commercial SATCOM because there is insufficient military satellite communications capability to support their needs. And part of that is the explosion of intelligence, surveillance, and reconnaissance needs that we talked about earlier, principally from a remotely piloted aircraft and streaming video and high definition data. It really requires significant bandwidth for the backhaul of that data, the exploitation of that data, and then the use of that for warfighting and other U.S. government needs. So beyond intelligence, surveillance, and reconnaissance, the more traditional needs for time-critical communications, internet access, and voice over IP to support those types of functions in addition to the intelligence, surveillance, and reconnaissance. So how can the U.S. government better utilize or leverage what the commercial SATCOM industry has to offer? Well, the first and foremost is they can help us understand what their emerging requirements are so that we can design satellites in the future to better support their needs. The second is that if they have a hosted payload need or opportunity that's out there, what we can do is we can work with them 3 or 4 years in advance of the need and determine whether or not we can support a launch and host a payload for their various missions. I'll use a specific example to illustrate the point. The Air Force wanted to better understand the emergence of the wide field of view infrared data that was being developed under an Air Force Research Laboratory project. It was a program called CHIRP, Commercially Hosted IR Payload, or Infrared Payload. We were able to partner with Space and Missile Systems Center, and from contract award to launch non-orbit capabilities, about 3 years. Further, we were able to demonstrate all the needs, 85% of the objectives that the Air Force had, for about 15% of the cost of what a dedicated satellite would have been. And this was all by taking advantage of an existing satellite, existing launch, and just really taking advantage of a ride to space and the real estate on the satellite when it was up and on orbit. The launch approach that we have was actually, and this took some negotiation, was launching from a foreign launch site, French Guiana, Kourou specifically, and leveraging a dual manifest where we had another satellite on board the launch vehicle, so we were able to share the launch costs. That was a huge differentiator in the overall scheme of things. But you know, it was a very small cost compared to the amount of capability that they got from the satellite and the CHIRP payload. And the CHIRP capabilities were highly praised by the Secretary of the Air Force and the Commander of Air Force Space Command for all the capabilities that they were able to achieve. SES has really taken a step forward in terms of their commercial satellite development and the tracking, telemetry, and control features. In fact, the parent company has invested a lot of money to make sure that they have NSA-approved Caribou Type 1 encryption capabilities for their TT&C, which makes them much more secure than if they had been another manufacturer without that capability. I think history has shown that with the CHIRP example as the backdrop, we have 2 other commercially hosted payloads that we're looking at in the near future, and it's roughly 3 years from contract award to on-orbit capability. Our experience shows that for U.S. government payloads, it's generally 6 years or more, and so we're probably cutting the time by about 50%.